everything before the vector concept. I've prepared vector too, but not 100%.
Okay, no problem. Mazia,
Yes, sir.
you have prepared?
No, sir, I didn't know. Like, only maths was told and bio yesterday.
Okay. Then in next class, I will take your Viva. Okay.
Yes, sir.
Okay, sir.
Please prepare only vector chapter. Okay.
Okay, sir.
Is it fine, Nabila?
Yes, sir.
Okay. Do you have any doubt from last class?
No, sir.
Okay. There is one more relation related to this. A dot B whole square plus A cross B mod whole square will give you A square B square. Now I'm giving you one problem related to this. If A dot B equals to root 3 times A cross B mod, then try to find theta between A and B. Use the above relation and simplify it to get theta. Should I solve? Raza?
Yes, sir.
Just use this relation as we have tan theta equals to A cross B mod divide by A dot B. So put the value of A dot B as given in the question. So you'll get A cross B mod divide by A dot B is root 3 times A cross B mod. Now this term and this term will cancel out. So you will left with 1 over root 3 equals to tan theta. Now the value of theta for which tan theta is 1 by root 3. So it will be just 30 degrees. Is it clear?
Yes, sir.
Yes, sir.
Just write it down. You all have written?
Yes, sir.
Yes, sir.
Next is projectile motion. So first, what do you mean by projectile? So you'll say motion of a body in two-dimensional plane that it will cover both x-axis or y-axis together, and it will be under the effect of gravity alone, then motion is termed as projectile motion. So you'll say the motion of a body in two-dimensional plane under the effect of gravity alone is termed as projectile motion. Now we may assume certain limitation, or there is some assumptions related to this. First is air resistance is neglected. So horizontal velocity will be always constant. Horizontal velocity will be always constant. And next is gravity to be constant. Is it clear? Mazia, any doubt?
No, sir.
Okay. Now we may break this projectile into two parts. One is called horizontal projectile, and the other is angular or oblique projectile. Just write it down till this part. You all have written till this part?
1 second.
Now, first is horizontal projectile. If a body is projected from this point horizontally at constant velocity u, so it will move along this path to hit the ground at this. Now, if you break the motion of the body along 2 dimensions, so it will be like initially at this point and horizontally initially at this point. It will move along this path due to horizontal projection to reach at this point finally, and it will move along this path due to the influence of gravity to hit the ground at this instant. Somewhere it will be at this, somewhere at this point, and this point. So we can say this body will have 2 different directions of motion. One will be along vertical path due to gravity, and one will be along horizontal path due to initial projection or due to initial velocity. So combinedly, we can say body is moving along plane. Now suppose at any instant, it will be at this point, for which final velocity will be along x-axis as vx and velocity along y-axis as vy. So resultant of these 2 terms will be along this path as v inclined at theta with respect to x-axis. So coordinate of this body along x-axis will be x, and along y-axis it will be y. Height from which body is projected is h, and total horizontal distance traveled by this body to hit the ground is r, which is also termed as range. So in this part, a body is projected horizontally at constant velocity u from height h above the ground, for which we can break its motion into two parts. First is motion along x-axis. So we'll have initial velocity along x-axis is u, and since it is constant, so acceleration along x-axis will be 0. Using two terms, we have to define first final velocity. So using equation first, it will be v is equals to u plus at. So it will be just u. Take it equation first. Using second equation, which is x is equals to or s is equals to ut plus half at squared. So it will be x is equals to u times t as acceleration is 0. So this will be equation 2. Similarly, if we define its motion along y-axis, since initially body is projected horizontally, so there will be no initial y component, and at each instant it will be acted by gravity so that it moves along downward direction. So acceleration along y-axis would be g. Using these two terms, if you have to find final velocity, v is equals to u plus a times t. So it will be gt, equation 3. And s is equals to ut plus half at squared. So it will be half gt squared is equals to y, equation 4. Is it clear till this part?
Yes, sir.
Sham?
Yes, sir, it's clear, sir.
Okay, just write it down.
Done, sir.
Raza, have you done?
Yes, sir.
Okay. Now, using these four equations, we have to define the different term related to this projectile. First is time of flight. Total duration of time for which body was in air, so it will be termed as time of flight. So put y is equals to h in equation 4th. You will get t is equals to root of 2h by gravity. Next is height of projection or height of throne. So just rearrange this previous equation of time of flight or put y is equals to h in equation 4th. You will get h is equals to half times gt squared. Next is horizontal range. Total horizontal distance traveled by the body from point of projection till it hit the ground is termed as horizontal range. So put the value of x to be r and t as time of flight in equation 2. So you will get r is equals to u times t, and it is equals to root of 2h by g. Nabila, is it clear?
Yes, sir.
Next is final velocity of hitting the ground. So it will be, as v is resultant of x component and y component, so it will be vx squared vy squared. As we have vx is equals to u and vy is equals to g into t. Put these two terms in this above equation, you will get final velocity of body at any instant. Next is direction of particle at any instant, which may be calculated by using tan theta equals to perpendicular divided by base. Perpendicular is g times t and base is u. So from this, you will be able to calculate theta, or inclination of direction of motion of body at any instant. Next is equation of trajectory. Trajectory is nothing but path traced by body during projectile motion is termed as trajectory. Path traced by body during projectile motion. So to define this, we must need an equation having x and y coordinate only. So just see in equation 2 and equation 4, if you relate them and try to remove t, so we can write from equation 2, t will be x divided by u. Put this term in equation 4. You will get y is equals to g divided by 2 times of u square times x square. So this is a relation between x and y, which will define path of projectile at any instant. So this equation is termed as equation of trajectory. Now in this part, since y is proportional to x square, which is nothing but equation of parabola, so you will say path of projectile is parabolic. You may find one last term, that is net displacement. So it will be root of x squared plus y squared, as x on hitting will become range and y will become height. So net displacement of particle from point of projection to hit the ground will be this term. So in this horizontal projectile, we may have to find these 7 different terms. Mazia, is it clear?
Yes, sir. Clear.
Okay. I'm giving you a 5-minute break just to pray, okay? Nabila, Raza.
Okay, so thank you.
Okay. Now, on the basis of these above concepts, I'm giving you one problem. A body is projected horizontally so that it hits the ground at 45 degrees in 3 seconds. Find first velocity of projection, second height, third range, fourth final velocity, net displacement. Try to find using above formula. To get this value u, just use tan theta equals to g into t divided by u. We have theta as 45 degree and t is 3 seconds. Just use these two terms, you'll get initial velocity of projection. Similarly, to find height, it will be half of gt squared. To find range, it will be u times t. To find final velocity, it will be root of vx squared, vy squared, in which vx is equals to u and Vy is equals to G into T. And to get net displacement, it will be root of R square plus H squared. Just use these formula and try to find.
So gravity will be 10, right? Yes.
Yes. Take the value of G to be 10. Nabila, mention the question number. Take your calculation. Tan 45 degrees equals to 1. Good, Raza. Good, Raza. Good, Nabila. You have to take magnitude only. Okay, Tasham? Good, Nabila. Sham, it should be in positive.
So gravity is negative, right? So minus 10.
Just 1 minute. If we take this particular point to be origin, so all upward term will be taken as positive and all downward term will be taken as negative. So in this path, height from this point to this point will be taken as negative, and gravity from this point to this point will be taken as negative. So if you put these two terms, you will get h is equals to ut plus half times ATA square. So this will be negative and this will be negative. So negative and negative will cancel out. So t will be, or tan theta will be, all of the term will be positive.
Okay.
Good, Nabila. Mazia, just send me your answer.
Yes, sir.
Good, Sham. Put all the values in first part as tan 45 equals to 1, g is 10, e is 3, divide by u. So u will be 30 meter per second. Answer first. Similarly, if you put values in the second part, you will get h is equals to half times g into t square. So it will be 45 meter. Answer number 2. Sham, just check your calculation. Nabila, your answer is correct.
Okay.
If you put the values of u and t in this third part, you will get r is equals to u into 3. So it will be 90 meter. Third answer. As initial velocity is 30, g is 10 and time is 3, so it will be 30. So final velocity will be 30 square plus 30 square. So it will be 30 root 2 meter per second. And similarly, if you put the value of r and height in this last part, it will be 90 square plus 45 square root under. Take 45 square as common. So you're left with 2 square plus 1 square root under, or it will be 45 root 5 is equals to net displacement. Any problem in this calculation?
No, Sakshi.
No, sir.
Okay. I'm giving you one more problem related to this. Suppose there is a stair having height and width of each step is h and w. Ball is thrown horizontally at velocity u. Find the nth step on which it will hit the stair. According to the question, it is like this. A ball is thrown at this point horizontally at some initial velocity u. So it will move along this path to reach at this point. Now, if you draw coordinate system for this, this is vertical line and this is horizontal line. As each step is h unit high, so nth step will be n times h, or the total height will be n times h. Similarly, each step is w unit wide, so the total width of n step will be range from this point to this point. Now use the formula of relation between range and height, put all the values and simplify it to get the value of n. Is it clear, Raza?
Yes, sir.
Okay, try to solve. as we have relation between range and height as r is equals to u times root of 2h by g. R in this example is n times w. U, height is 2 times n into h divided by gravity. Squaring both sides, it will be n squared w squared is equals to u squared 2 times n into h divided by gravity. This 2 and this n will cancel out. So if you rearrange it, you will get n is equals to 2 times u square h divided by g times w square. So this will be the nth step on which ball will hit the stair. Nabila, is it clear?
Yes, sir.
Yes, sir. Clear,
Okay.
sir.
You all have written?
Yes, sir.
So 1 second.
Okay.
Done, sir.
Next is angular projectile. Body is projected from this at some initial velocity u at inclination theta with respect to x-axis. So it will have two components. One would be along x-axis and the other would be along y-axis. So it will be u cos theta and u times sine theta. Now, this body will move along two different directions. One would be along x-axis and the other would be along y-axis. Initially, it is at this point. So it will move along this horizontal path due to u cos theta. So at some instant, it will be at this point, this point, this point, and finally it will reach at this point. So total horizontal distance traveled by this body during this whole motion is termed as horizontal range. While going in vertically upward, it will move along this to reach highest point, and then return back along this path to hit again. So it will move up due to this u sine theta to reach at this highest point and then return back to hit ground at this instant. So we can say this body has movement both along x-axis as well as y-axis. At highest point, vertical component velocity will be 0. So it will left with only horizontal component, that will be u cos theta. As we had learned in chapter number 3 in motion of gravity, at same horizontal level, velocity of body or velocity of throwing of a body and velocity of hitting back to the ground must be same. So since body is projected with some initial velocity u, so on hitting the ground, it must have u velocity and it must incline at same inclination theta. So if you break its component, so it will be u cos theta and u times sine theta. A body is projected at theta with x-axis at velocity u or at constant velocity u. So we have two different components. One is initial velocity, which will have two components. One is u cos theta along I cap plus u times sine theta along j cap. Similarly, we have final velocity as u times cos theta I cap, but the direction of y component get reversed, so it will be minus of u times sine theta j cap. So just remember, only there will be change in y component from v initial and v final. So using these two terms, we can calculate average velocity. So it will be v initial, v final divided by 2. If we simplify it, you'll get u cos theta along I cap. Similarly, change in velocity will be v final minus v initial. If you put all the above values, you will get minus of 2 u times sine theta j cap. Is it clear?
Yes, sir.
Okay, just write down till this part. You all have written?
1 minute. Done.
Okay. Raza, done? Okay. So next is to define motion along respective coordinate axes, that is x-axis and y-axis. Motion along x-axis. Initial velocity along x-axis is u times cos theta. And since this velocity is constant, so acceleration along x-axis will be 0. So using these two terms, if you find first final velocity along x-axis, it will be u times cos theta as equation first. Similarly, using second equation, it will be x is equals to u times cos theta into t as acceleration is 0. So this will be equation 2. Similarly, motion along y-axis. Initial velocity of y-axis is u times sine theta, and acceleration along y-axis is, take this particular point of thrown to the origin, all of upward quantity will be positive and downward quantity will be taken as negative. So gravity will be negative here. So using first equation of motion to find final velocity, it will be v is equals to u times a into t. Equation third. S is equals to ut plus half at square. So it will be u times sine theta into t, half of gt squared. And last, using third equation, it will be v squared is equals to u squared minus 2gy. Now using these equation, we have to find first time of flight. Time of flight means the total time taken by body or elapsed body during this whole motion. Time of flight. Put the value of y to be 0 in equation 4. You will get u times sine theta t minus half of gt square is equals to 0. If we take out t as common, you will left with u times sine theta minus g over 2 into t is equals to 0. Now, if you put individually this term and this term equals to 0, you will get t is equals to 0. And from this, it will be t is equals to 2 times of u sine theta divided by g, which means if t is equals to 0, which will be starting point or point of projection, and t is equals to 2 times of u sine theta divided by g is the total time traveled or taken by the body for this entire motion. So this time will be termed as time of flight. Mazia, is it clear?
Yes, sir.
Okay. Similarly, next is to define height attained or maximum height attained by this projectile. So put Vy to be 0 at its highest point and y is equals to h in equation 5th. You will get 0 is equals to u times sine theta whole square minus 2gh. So on simplifying, you will get h is equals to u square sine square theta divided by 2 times gravity. So it will be maximum height attained by this projectile. Nabila, is it clear?
Yes, sir.
Next is horizontal range or horizontal distance traveled by this body. So put x is equals to r and t is equals to time of flight in equation 2. You will get r is equals to u times cos theta. Time of flight is 2 times of u sine theta divided by gravity. So it will be u square 2 times sine theta cos theta divided by gravity. I have defined you in trigonometric part. This formula will be nothing but sine of 2 theta. So it will be u square sine of 2 theta divided by gravity is equals to range. Raza, is it clear till this part?
Yes, sir.
Okay, just write it down.
Thank you, sir.
You all have written?
Yes, sir. Done.
Raza?
Yes, sir. Done.
Okay. Next is to define equation of trajectory. As from equation 2, we can say t is equals to x over u times cos theta. If you put this in equation 4, you will get y is equals to x as we have y is equals to u cos u times sine theta into t minus of half gt squared. If we put the value of t to be x by u cos theta, you will get u sine theta times x over u times cos theta minus half g x squared divided by u squared cos squared theta. If you simplify it, you will get u and u will cancel out. So it will be x times tan theta minus g divided by 2 times of u squared cos squared theta times x squared is equals to y. So this will be equation of trajectory for this path. Since y is directly proportional to x squared to the highest power, which is nothing but equation of parabola. So you'll say path is parabolic in nature. Okay, just write it down. I'm giving you problems related to this. If a body is projected at eight I plus 10J, find first final velocity, second angular projection, third range, maximum height it would attain, and time of flight. Just write it down. I will define you how to solve it.
Sir, I'm sorry. I thought that the class ended because there were only 5 participants.
Okay. You all have written till this part?
Yes, sir.
Okay. In this question, we have a body is projected at 8 I cap and 10 J cap. So V initial is 8 I cap plus 10 times J cap. So according to the concept, final velocity of hitting the ground will be only change in direction along y cap or in y direction. So it will be 8 I cap minus of 10 j cap as their final velocity. Is it clear?
Yes, sir.
Yes, sir.
Yes,
Next
sir.
is if you break this particular component, as we have v initial is equals to 8 I cap plus 10 times j cap. So this will be nothing but u times cos theta, and this will be u times sin theta. So if you divide these two terms, you're left with u and u will cancel out. Cos divided by sine will be cot theta equals to 4 divided by 5. Using this relation, if you draw a triangle, let this be theta, as cot theta is ratio of base and perpendicular. So this will behave as base and this will behave as perpendicular. So it will be 4 divided by 5. So using Pythagoras theorem, you will calculate this hypotenuse as 5 square and 4 square. So it will be 25 plus 16 root of 41. Is it clear?
Yes, sir.
Now we have to find theta. So from this, you will say theta will be equals to cot inverse 4 by 5. Next is you have to find range. Formula of range was u square times 2 cos theta into sin theta divided by gravity. So we have to find first u. If you put the value of theta in any of these equations, u cos theta is equals to 8. U cos theta from this triangle would be base over hypotenuse. So it will be 4 divided by root of 41 is equals to 8. So on solving, you will get u is equals to 2 root 41 meter per second. Put this value in this part, you will get range. So u square will be 2 root 41 into 2 root 41 times 2. Cos theta is base over hypotenuse, so it will be 4 divided by root 41, and sin theta is perpendicular over hypotenuse, so it will be 5 divided by root of 41, whole divided by gravity, which is 10. This root 41 will cancel out with this and this part. 2 into 5 is 10, so it will cancel out with this part. So you will left with 2, 2, and 4. So it will be 16 meter as horizontal range.
Sir, by 2, right? Because 1, 2 will be left. 5 ones are 5, 5 twos are 10.
No, I have taken this 2 and this 5.
Okay, sir.
Similarly, to get height or maximum height attained, it will be u square sine square theta. So it will be sine theta into sine theta divided by 2 times of gravity. So put the value of u to be 2 times under root 41. Sine theta from this triangle, it will be 5 divided by root 41, and g as 10. You will get a value for maximum height attained by the body. Similarly, for time of flight, it will be 2 times of u sine theta divided by gravity. Just try to find these two different values. Sham just put the value of sine theta from above triangle.
Yes, yes, yes.
Just see how to simplify it. As we have u is equals to 2 root 41. So square of it would be 2 root 41 times 2 root 41. Sine theta is perpendicular over hypotenuse. So it will be 5 divided by 41. 5 divided by 41. Divide by 10. This root 41 will cancel out with this and this part. 2 into 5 will cancel out with this 10. So you're left with 2 into 5 only, which is 10 meters. And now if you put values in this second part, you'll get 2. U is 2 root 41. Sine theta is 5 by root 41 divided by 10. Root 41 will cancel out. This 2 and 5 will cancel out with this 10. So you are left with just 2 seconds. Is it clear? Raza?
Yes, sir.
Now I'm defining you some more relation related to these so that it will become more easier to solve these type of problems. You all have written?
Done, sir.
Mazia, done?
Yes, sir. Done.
Okay. So next is relationship between these terms. To define relationship, between time of flight, which is 2 times of u sine theta divided by gravity. Range is equals to u square sine 2 theta divided by gravity. And height is equals to u square sine square theta divided by 2 times of gravity. So first, try to expand and divide these two terms to define the relationship. Since in this first part for time of flight, we have only u, but in just the two term, that is for range and height, we have u square. So we will take square of this time period or time of flight. So it will be t square is equals to 4 times of u square sine square theta. So it will be sine theta into sine theta divided by gravity square. So it will be g into g. Similarly, if you expand this formula, you will get u square 2 times sine theta into cos theta divided by gravity. And for height, it will be u square sine theta into sine theta divided by 2 times gravity. If you have to relate between first two terms, that is time of flight and range, and similarly between range and height, just divide these two terms, range and time of flight. So t square is 4 times u square sine theta into sine theta divided by gravity into gravity. This is first part. If you put the value of range in this part, which is u square 2 times sine theta into cos theta divided by gravity g. Now just simplify it, you'll get your relationship. Similarly, to define relation between range and height, as range is u squared 2 sine theta into cos theta divided by gravity, and height is u square sine theta into sine theta divided by 2 times g. So on simplifying, you'll get in first part, this gravity and this gravity will cancel out. Sine theta will cancel out. U square will cancel out. 2 in 2 times will be equals to 4. So we're left with 2 sine theta and cos theta in right hand side and t square over r in left and g as well. So if you rearrange it, you will get gt square is equals to 2 times r sine theta by cos theta is tan theta. So this will be your first relationship between time of flight and range. Is it clear?
Yes, sir.
Yes, sir.
Now, similarly, in the second part, u square will cancel out. Sine theta will cancel out. G and j will cancel out. So you're left with 2 into 2, that is 4. And sine theta and cos theta moving to the left hand side, it will become tan theta is equals to 4 times h. Now, if we may reduce these two different expression to one, so we may write it as gt square is equals to 2 times r tan theta is equals to 8 times h. So this will be final relationship between all these three terms. So just remember only this part. Just write it down to this.
So can you go a bit up?
Okay. I think you all have written to this.
Yes, yes, sir. Yes, sir. Yes.
You all have written?
Yes, sir. Done.
Yes, sir. Done.
Nabila, done?
Yes, sir.
Okay, so this is all about today's class. So just divide this whole part and try to do more and more problem. In next class, I will define you some more concept related to this, and then we'll start the last topic of this chapter, that is relative motion. Okay? And there will be Viva in next class. You'll have to prepare till product affected.
Okay. Sir.
Okay then,
Thank you, sir.
thank you.
Yes.
Thank you, sir.
Thank you.
Thank you.
Bye.
Bye.
उसी में अब 2 या और कोई